Hi, and welcome to episode 5 of our continuing series on Proto AI's Gestalt AI. Today, we're going to be talking about some of our case studies and some of the results we've seen. So, when we began to implement the Gestalt AI, we started with a well defined market and providing product recommendations on e commerce platforms. It was a well understood service offering that already exists in the industry, and we wanted to see how our system compared to those that use standard data modeling techniques like affinity threading. So, Nick, take us through some of the results we have seen on various types of sites and business industries.
So we've had a pretty wide range of deployments in terms of the size of the sites we've worked with, the things they sell, the amount of traffic they get. Some of them monthly revenue is measured in hundreds of dollars. For some of them, it's measured in hundreds of thousands of dollars. So there's a pretty big range here. Um, but basically, across all scales, we observed an order of magnitude improvement versus randomly generated recommendations. More precisely, if randomly or when recommendations were randomly generated, we typically saw something like tens to hundreds of dollars in direct revenue generated by our product. Whereas over the same time period, we saw more like thousands or tens of thousands of dollars when the recommendations were AI generated. What I mean by directly attributable revenue here is revenue where the causal link between interacting with the recommendation generated by the AI and the purchase is about as close to unambiguous as possible. So there's a lot of fuzziness that can go on here. And what we mean is a user saw a recommendation, clicked on it, added it to their cart, and purchased it all within one use session. So there's no ambiguity there. In terms of indirect effects, things that are slightly less unambiguous, we also saw statistically significant changes in terms of the behavior of people who just looked at recommendations. So what does that mean? Well, when recommendations were made randomly and users saw them, their behavior didn't change measurably. They just saw the recommendations and then continued along the way. There was no in-group, out-group separation, no statistically meaningful variations, nothing like that. With recommendations generated by the AI, when a user views the recommendation, it actually does, in a statistically significant way, change their behavior. They're more likely to complete a purchase if they add that item to their cart down the road. They're much more likely to revisit the item and later click on it to look for more details, even if they didn't click on the recommendation itself. And they're actually more likely to complete a purchase in general. Comparing across sites, when our recommendations were more visible, all of these positive effects scaled up according to how much more visible the recommendations were. In other words, if 20% of the visitors on a site interacted with the AI, this was proportionally more effective than if only 5% did. It's possible there's a plateau in there somewhere where if, what's the difference between 60% of people who go to the site interact with the AI and 100%? The answer is we don't know because that didn't happen. There were also several instances of what I'm going to call product lift, where products had their frequency of sale increased in proportion to the rate that they were recommended. More precisely, this is when the AI saw the opportunity to recommend a product that didn't sell very frequently and actually resulted in a directly measurable increase in the rate at which that product sold. So this is an expansion of the list of things that typically sell. Taken as a whole, these observations make it pretty clear that the Gestalt AI does have efficacy and that the on-demand momentary models that we discussed previously do have a distinct and significant effect when compared to random recommendations and even when compared to broader, more global state-based approaches like, as you mentioned, affinity threading or collaborative filtering or all those other sorts of approaches where they're really working with a global state model that's actually based on the items, not necessarily the individual people visiting the site.
Thanks, Nick. So, Jeff, what do you see coming for AI in general and Gestalt AI in particular? And can you give us a peek at the future uses of Gestalt AI?
All right. Well, to kind of answer that, let's take into account some of the history of AI before we go too deep into those cases. There's a pattern in AI development which has been repeating during its entire lifetime. It comes to a summer event where some innovative idea comes forward, and then that gets turned into methodologies, tools, and techniques and software. And then that carries forward until the capital can exploit it into the market. And it gets to a point where it hits some form of scaling event. That's where you move from an AI summer to an AI winter. The scaling event doesn't have to be technological. It could also be a business problem. But in the history of artificial intelligence, if you hit a scaling limit in the progression of that, what happens is the AI stops moving forward and it goes into kind of a dormant period where people are looking at what worked, kind of trying to pick up the pieces, polishing them up, codify them to do the best to make them into future tools. Gestalt AI has a chance to break that entire cycle. And the reason is Gestalt AI has a big advantage in solving problems that are related to scale, whether on business side or in the case of technology. So let me kind of walk through what that looks like a little bit. So if you take eight to 9 domains of knowledge that are going to be run with the AI, and you wanted to service those, you could go down to Kmart or Walmart or someplace like that and buy just a normal desktop computer, and it would service those capabilities and run the AI on it all by itself. So we're running on just normal CPUs, no GPUs. We're running on reasonable amounts of RAM, and we have a reasonable scaling set, and we can scale this out horizontally. Now, the AI is currently deployed in the cloud, and we're carrying it forward to massive cloud scale over this year. It's directly in our development path immediately. What does that give us? Well, if you can kind of consider that on a typical computer that I talked about in the case that I cited, that you could handle, say, 1,000 observations a second being encoded and driven into data, learned from, grouped, and then come back with answers for those customers. That's something we're running now, and we're making it better over time. So that's a fairly good starting point to scaling up the capability we have in hand. Now imagine we smear that across the entire cloud and all the CPUs up there, not the graphics processor units that are being used by other AIs. There's not even a contention over the resource. We're running across good old Xenon or Ryzen processors that are up in the sky, and off we go. The advantage of this now is we can then take those AIs that are in that one compute area, the cloud, and get them to begin to cooperate to solve problems. So we can solve the same kind of problems for many customers. Now we have engaged customers. And then we go and we bring all kinds of additional value to them in all kinds of domains of knowledge. And we lift and cross that knowledge solve so that we're getting even more power delivered in the form of artificial intelligence with new applications and new ways of sharing data between them. And that can run from the current design footprint right now. Where we're heading down the road is to move toward kind of an SDK development system so that we can have people do custom implementations that then are validated and dropped directly into our AI as part of the cloud infrastructure. And we'll be developing that in the next year or two and have it tested in development for people to play with. So now assume that we break that barrier. This is an assumption. We think we can, but just ride with me for a second. We break that barrier. We put that power in developers' hands all across the planet, and they all start solving problems at once. How fast do we get way down the road on massive solves in artificial intelligence at a very cost-effective structure and serve that lift to the entire planet? So I'm going to imagine something that I'm actually kind of working on my own with collaborations with some of my friends who are in the area of child development, and they want to be able to help grow up better babies, help them develop better mentally, physically, and be ready for life better. It's a personal passion of mine, and it's something I've been thinking about and working toward for a long time. Well, that kind of AI is an ensemble AI. There are 11 disciplines of different knowledge being applied to the development of the child, from the case of their gripping motion, their standing motion, their speech patterns, their hearing, how they perceive and understand things. Imagine that AI is integrated into a family unit and able to help a child who has a developmental delay and manage that process and drop the competency that's needed into the life of the caregivers around the people who need it, whether that's a child, a disabled citizen, or an elderly citizen. Now we begin helping human expression and humankind. We have the capability to do that kind of stuff with this AI because we can solve each problem separately and then fit them together and put finishing on it, and it's ready to run. It's distinct separate development that can be done by many teams all at once. And at the end, you put the pieces together, clean it up, and solve the general problem you want. And if you need to change it, the power of the AI allows you to go in and change out modules from one thing to another, and it can actually be redefined and come live, and that's on the existing data that's there. We store the data in the AI in a fuzzy manner, which means we can grow all kinds of information on any data point in any direction we want to. We store all the data in the AI in a ragged manner, meaning you don't have to have all the data to solve something. You only have to have some of it. So we have great power in the capability of what we have as a platform to build on. And we're building that out to solve, in this case, in the case of ecom, which is what Nick was referring to, and we'll put some more information about that in the next episode. We're solving what Google calls a tactical AI deployment, meaning people who don't have their own AI people and don't have all the expertise they need. And we're bringing a solution where we're substituting the expertise that's in the AI's capability and deployment into their organization. We're reaching further down into the infrastructure of the business enterprise to smaller clients and serving them with first-class results. We're doing it deeper, wider, and more generalized. And we can keep adding features and benefits in here. Like we can take a recommendation engine and we can add labeling, which allows us to create different kinds of grouping used for all kinds of reasons. And that's coming online literally in the next month or so. And then right behind that, we can add in all kinds of intelligent search operations. Well, you would think that would be a whole new AI. It's not. It's the same data. It's all the existing infrastructure, and it's just looking at the AI with a new the data that's there in that domain with a new application, and it's able to apply that knowledge rapidly. And whatever else we can conceive of, whatever we can dream of, whatever we can reduce to a practice of applied mathematics that we can build. Ecom is 3,400 lines of C#.NET code. It's about as plain vanilla as you can possibly do to get an AI to deploy.
We've been talking about our Gestalt AI. We call that AI Seraphim. We are actively looking for new ways to apply this breakthrough. If you have an idea or a problem that you'd like to try and solve, please contact us to get on our waiting list.